This device is a simple electric motor. I'll explain how to construct this motor and discuss some of the science behind its operation. Electric motors convert electrical energy into mechanical energy. They use the push and pull of magnetic fields to create rotary motion. British scientist Michael Faraday is credited with demonstrating the first simple electric motor. He created this device in 1821 and called the effect electromagnetic rotation. If you have viewed our video on magnetism, you will know that the opposite poles of magnets attract and the like poles repel. The poles are labeled north and south. Rotating this disc ceramic magnet moves the compass's magnetic needle. Red represents the North Pole. You may also know that a magnetic field appears when current flows in a conductor. Briefly connecting this wire to a battery deflects the compass's needle. Electricity creates a magnetic field. This effect can be used to create an electromagnet. This coil is the electromagnet in our simple motor. Connecting a AA battery, we can see the magnetic force from the coil moving the magnet in the compass. The coil is polarized. One side is north, the other is south. Let's start construction of our motor by creating the coil. You'll need 1.5 meters of 25 gauge magnet wire. This wire is specially designed for creating motor coils. Other similar gauge insulated wire will work, but this wire is best. To create the coil, wrap the magnet wire onto a AA battery. Wind a tight coil. Leave both ends of the wire exposed, about 4 centimeters. Carefully slide the coil off of the battery. Loop the two ends around the coil 2 or 3 times. Note that these securing loops are tied directly across the coil from one another. This is important. The 2 short exposed leads will act as the shaft for our motor. It is important that they are centered or the coil will not be balanced. This wire is coated with an insulator, typically an enamel. We must remove the insulation from the 2 leads to allow electricity to enter the coil. Use a small piece of medium grit sandpaper. I'm using a 100 grit paper. Fold the piece and pull the abrasive surface over the metal leads. Rotate the coil so the insulation is removed all the way around. Note the color of the exposed copper metal. The enamel coating is difficult to remove and requires a lot of effort. Sanding may stretch the wire. Just loop the excess back through the coil. This completes the coil. Next, we need some metal brackets. Any thin metal is suitable. Aluminum baking sheets work well. Cut 2 brackets 1.5 centimeters by 5 centimeters. Fold them in the center. Make a small hole centered and very close to one end of each bracket. You can create these with a push pin or small drill. The wire leads from our coil fit through these holes. You will need a permanent magnet for your motor. Disc ceramic magnets like these work well. Using a line or straight edge, align the 2 brackets on a block of wood. Use the magnet as a spacer. Leave a small space between the magnet and bracket. Use thumbtacks to secure the brackets to the block. You may want to pre-punch holes in the bracket to make it easier to push the thumbtacks. Use the thumbtacks to secure a wire to each bracket. Make sure that you have a metal-to-metal connection. Electricity must flow through the wires to the bracket. Next, mount the coil by sliding each end into the holes in the brackets. Make sure the coil is centered and balanced and doesn't hang like this. Rebend the wires if needed. The coil should be aligned like this. Slide the permanent magnet into place. It doesn't matter which pole is up. Touching the leads to a single AA battery should cause the coil to bounce. If the coil is balanced and all electrical connections are completed, the motor should start. Only use a single 1.5 volt alkaline AA battery for this motor. A different power source can be dangerous, causing excessive heating. Often a few bounces will start the motor, but sometimes it is necessary to flip the coil to get it started. Use a pencil if you need to flip the coil while connected. The coil gets hot. If your motor refuses to start, disconnect the battery and let the coil cool for 2 minutes. Resand the coil leads and check to make sure the leads are straight and centered. Sometimes flipping the permanent magnet or reversing the battery leads will help. Electricity is a flow of electrons. The electron flow through this motor starts at the minus end of the battery. Electrons travel through this wire to the metal bracket, through the bracket to the first coil lead. The electrons travel through the coil, creating a magnetic field that interacts with the magnetic field of the permanent magnet, creating rotary motion. The circuit is completed with the connection back to the positive terminal of the battery. This is a commercially made DC motor. It is significantly more powerful and efficient than our simple motor. It accomplishes this with strong permanent magnets and large coils wound on an armature, and a method for controlling the polarity of the coil's magnetic field. Pulling the end off of the motor reveals brushes and an armature. The armature is the structure that holds the coils. Inside the motor housing, there are 2 large magnets, the field magnets. These powerful magnets interact with the field produced by the coils on the armature to create rotary motion. Direction of current flow through the coils is controlled by a switch called a commutator. These metal bars on the commutator are connected to the coils. Brushes deliver current to the contacts on the commutator. These brushes are made of carbon. They are connected to the external power connectors on the motor. The rotating contacts flip the direction of current flow, which also flips the polarity of the magnetic field, resulting in a powerful push-pull between the 2 fields. Similar technology can be found in motors powering everything from toys to locomotives. One of the more exotic uses of electric motors can be found in the motors enabling Curiosity, NASA's rover. Moving with electric motors, this sophisticated robot is traveling across the surface of Mars. Faraday would be amazed to see how far his discoveries about the relationship between electricity and magnetism have taken us. A safety reminder. If you attempt to construct this electric motor, do not use any power source other than a single 1.5 volt AA alkaline battery. Disconnect the battery for 2 minutes before touching the coil. It is hot when the battery is connected. Add a label to your motor warning that the coil gets hot and only a single AA battery is a suitable power source. More information about this and other projects can be found at our website, hylaroad.com. Follow the projects link.